So here's another exercise from 7.1. A central angle theta and a circle of radius 7 centimeters is subtended by an arc of 5 centimeters. Find both the degree measure and the radian measure of the angle theta. So we have this kind of a picture going on where you have some central angle that we're trying to find. I'll label that theta. We know the radius is 7 centimeters. We know this arc length is 5 centimeters. And we want to find theta in both radians and degrees. Again, I think there's another problem where I think there's sort of a fast way to do it and a longer way. I think the fast way is to find radians first. You can say theta in radians is S over R. So the radian measure of theta is that arc length, 5 over 7, and you're done with the radian measure. Let's just sort of plug in to our formula for radian measure. Then convert to degrees. And you can either use a proportion or you can use our second method where you multiply by a fraction equal to 1. Let's maybe use the second method here. 5/7 radians. I think when I did one of these with a fraction, I wrote it over 1 just to make it easier to decide the fraction we want to multiply by. We want to cancel radians, and we want to end up with degrees. We want to keep degrees. So I'm going to write 180 degrees over pi radians. That's what I multiply by. The radians will cancel, and I'll end up with an answer with degrees. And I can write this left-hand side as just 5/7. 5/7 over 1 is 5/7 times 180 over pi, and I'm going to end up with units that are degrees. I don't think anything cancels here. I don't think 7 goes into 180. So I'm just going to multiply across. 5 times 180 is, I think, is it 900 over 7 pi degrees is actually the exact value with degrees. I can't make that pi go away. And let's come up with a decimal for this, decimal value of degrees. 7 times pi. I'm actually, I'm okay, when I work through that, I'm getting that this is about 40.9 degrees. And now I want you to check this on your own on a calculator to make sure you get the correct value. I have a lot of students who will make a mistake on this problem with the calculator where they do 900 divided by 7 times pi, and I'm going to do that right now. 900 divided by 7 times pi, and I get 403.9. That's wrong, because the calculator is is interpreting what you're entering in the following way that is not what we want. It's thinking you want 900 divided by 7 times pi over 1 if you get that value. If you want to get the correct value here, it's a good idea to learn to use parentheses on your calculator. So if you do 900 divided by, because we have a complicated denominator, start a parentheses, then do 7 times pi, close parentheses. I'm going to do that right now here, clear. 900 divided by parentheses, 7 times pi, close parentheses, equals, and there's my 40.9, so that's correct. So watch out for this calculator error, which is very common. I see a lot of students making it. They're not using their calculator properly to get the value that we want. When you have a complicated denominator, learn to use parentheses on your calculator to get the correct decimal value. Okay, so that's the fast way to do that problem. I was also going to just mention an alternate way, because we don't always see the fast way the first time we try to solve a problem. I'll have some students set up a proportion in the following way, where they write theta in degrees over 360 degrees is equal to the arc length, 5 centimeters, over the circumference of the circle. And let's see, the circumference is 2 pi r. That's 2 pi times 7, or 14 pi centimeters. So we're going to plug that in here. So theta, now remember that's theta in degrees over 360 degrees, is 5 over 14 pi. And you can solve this equation to get directly to the degree measure of theta. You're going to multiply both sides by 360 is one way to proceed. So I would have on the right 5 over 14 pi times 360 over 1, and 5 times 360 is, this would look like 1800 over 14 pi, which is can be reduced to 900 over 7 pi. I think that's the only way you can reduce it and keep an exact fraction. So there's that same answer we got above. But then you still must convert to radians. Right? So let's just see what that would look like. Again, it is much longer, this alternate way. So we would have to take 900 over 7 pi degrees, I can write that over 1, times, now I want degrees to cancel. I want to end up with radians. This is sort of a big mess this way. Pi radians is 180 degrees. So it ends up looking like 900 over 7 pi times pi over 180. Notice that the pi will cancel along with the degrees that have canceled. And we end up with 900 over 7 times 180. This is going to reduce down to 90 over 7 times 18. 9 goes into 18 twice, into 90 10 times. I get 10 14ths, which is 5/7 radians. There's that radian measure. So this is sort of a weird, not such a weird way, alternate way to proceed. Let's see if I can get this all on the screen. It works just fine. You find degree measure first, and then you still have the mess to go through to convert to radian measure. Certainly the fast way was the first way, so I'm going to endorse that at the end. And we're through with that one.